Hi everyone, you are welcome to DML Physics Concept. Today we'll start looking at the application of the formulas which we learned in our previous classes. In previous classes, we started by looking at current electricity, and in those videos, we've looked into the concept of current electricity. We've talked about Ohm's law and some ohmic conductors and many other things like that. And at the same time, even in the second video, we looked into uh, arrangement of resistors in series and parallel, and we deduce, we prove the formula, how we get the formula to find equivalent resistance when the arrangement of the resistors are in series and also when the arrangement of the resistors are in parallel. So today we'll be looking at the application of those formulas as we did in the last previous classes with some of the examples. So, but before we can proceed in this place, if you want to go over those previous classes so that you can have a better understanding of what we want to do today, you can just go to the description of this video, check the description link. I will send the link to those two videos in the description. So just go over those topics, watch it to the end. Make sure you watch those videos to the end to get the full concepts. Please don't just pause and watch few, just make sure you watch the video to the end so that you can get the full informations and the full concept of what you need. Now today we'll be looking at this the application of those formulas. So let's start with example 1. But before I give you this example, it's very important to know that when we are dealing with current electricity, what we are dealing is that we want to measure the voltage, the current, and the resistance in the circuit. So whether the circuit is a series arrangement of resistor or parallel arrangement of resistor. So what we want to determine is to measure the voltage, the current, and the resistance in that circuit. But before we begin to determine the resistance and the voltage in the circuit, it's very important that we understand very well how to find equivalent resistance. If it is a series combination, how to find equivalent resistance, and if it's a parallel combination, how to find equivalent resistance. And even if I give you the combination of the two circuits, it's very important to know very well. So I will start with that examples before I now move into what we have for today. So let's look at this example 1. In this example 1, the question is find the equivalent resistance of the circuit above. Find the equivalent resistance of the circuit above. If you look at the circuit connection, you see it's a series connection because if current starts from this point, current flows directly into the three resistors. So therefore, they have the same current. So let's find the equivalent resistance because that's the first thing you should know. Before we start looking for voltage, current, we must first know how to find equivalent resistance. So in this case, our formula is going to be R total, or R equivalent is going to be R1 plus R2 plus R3. So that's going to be our formula. So we just say our R is going to be 2 plus 4 then plus 3. And 2 plus 4 plus 3 is going to give me what? That is 4 plus 2, 6, 7, 8, 9. That is 9. And the unit is ohms. So for example 1, so we are going to have 9 ohms. So let's look at example 2. So let's look at example 2. In example 2, we are also asked to find equivalent resistance. If you look at this connection, it's a parallel connection. How do I say it's a parallel connection? Let's say current is flowing. When current gets here, then current need to split into 3. Part of the current will flow through these first 2 ohms. One will flow through this, and the other will flow through this. Then later they come out together and then come out. So which means the current have to split into 3. So in this case, the arrangement of these cells, of these resistors, is in parallel. So how do we find the equivalent resistors? Just say the formula is 1 over R equals to 1 over R1 plus 1 over R2 plus 1 over R3. So that's the formula when we are dealing with resistance in parallel. So we just say 1 over R is going to be 1 over 2, that is for R1, plus 1 over 2, that is for R2, plus 1 over 2, which is called, that's the R3. So resistance 1 is 2 ohms, resistance 2 is 2 ohms, resistance 3 is 2 ohms. That's why we have 2, 2, 2. So let's find the LCM. And the LCM is 2. And if the LCM is 2, you know that this one is going to be 1 plus 1 plus 1. So 1 over R is going to be 3 over 2. So what's our resistance in this case? Our resistance in this case is going to be 2 over 3. 1 over R is 3 over 2, but we are not looking for 1 over R. It is the inverse of resistance, that is 3 over 2, but we are looking for the R, which is the equivalent resistance. So it turns upside down, you cross multiply, and finally you find the value of R, and R is going to be 2 over 3 ohms. So for this case, our resistance, or the overall resistance in this circuit, is the 2 over 3 ohms. So let's look at example 3. So let's look at this example 3. In this case, we are also asked to find equivalent resistance in this circuit. So in this circuit, so can we say it's a series? No. Can we say it's a parallel? No. So this kind of circuit shows a combination of series. Why do I say it's not only series? If current flows here, it enters this place, good. But when the current gets here, it has to split to pass through these two resistors. So what we are going to do is that these two resistors, they are parallel, but the combination of the two of them, when we bring it together, becomes series with this. So first thing we need to do is that we deal with this parallel circuit. So let's first find this parallel combination. Let's add this together. So for this one and this one, we see 1 over R equals to 1 over R1 plus 1 over R2. So 1 over R equals to 1 over 2 plus 1 over 2. This is the R1, this is R2. So 1 over R is going to be, find LCM is 2, and this is going to be 1 plus 1. So 1 over R is going to be 2 over 2. So if 1 over R is 1, that 2 over 2 is 1. So 1 over R is 1 ohms, and therefore R is also, if I cross multiply, R is 1 ohms, because inverse of 1 is also 1. So in this case, this one has come together to be 1. So we can redraw the circuit to now become like this. So this is the 2 ohms, and this one, the combination of these two, we have added it up together to give us 1 ohm. So this one is 1 ohms. So find the equivalent resistance in the whole circuit. So the equivalent resistance in the whole circuit is R, because this one is now in series. R equals to be R1 plus R2. So the R total is going to be 2 plus 1, and 2 plus 1 is going to give us, so it's going to give us 3 ohms. So in this connection now, the equivalent resistance in this connection is 3 ohms. The total resistance is 3 ohms. So let's look at another example, example 3 now, example 4. So let's look at this example 4. So we want to find equivalent resistance in this circuit too. So what we need to do is, we start from this point. So when current flows through here, this one, current gets to this. But once the current gets here, it's split into this and this. Never say a current is like this, this one is series. No, don't do that. Immediately you are tracing your line and you get to a point whereby there is a split, you have to deal with that parallel connection before you now say you want to deal with series connection. So as current is flowing like this, for the fact that at this point it has to split into two, you need to first deal with this parallel connection. So telling me that simply means that this one, these 2 ohms and these 2 ohms, they are parallel to each other. So let's first solve the parallel combinations by saying 1 over R is going to be 1 over R1 plus 1 over R2. So 1 over R is going to be 1 over 2 plus 1 over 2. And 1 over R is equals to, find the LCM, that is 2, that is 1 plus 1. Then 1 over R is going to be 2 over 2. So therefore our R is going to be 1 ohms. If 1 over R is 1, then the inverse of 1 is also 1. So we are going to have 1 ohms. So it means these two resistors has been combined together to give us this 1 ohm. So you can redraw the circuit by doing it this way. So you draw the circuit like this now. So in drawing this way, it means this one is the 1 ohm. So these two has come together to become 1 ohm, and this is the 1 ohm. Now you can now trace. So when you trace now, you discover that there is no splitting again, no splitting of current. So the current in this case is now become a series connection. So for series connection, our R is going to be R1 plus R2 plus R3. So we just say our R is going to be 1 plus 1 plus 1. It's going to be 3 ohms. So the overall resistance in the circuit is 3 ohms. I want you to watch this video to the end to get a better understanding of what I need you to get. So let's look at this example 4. Find equivalent resistance. So in this case, can we say they are parallel? Can we say they are series? So what we are going to do here is we must first trace the current from a certain point. So since it's not floating, like this. For instance, if you have something like this now, we can see it's floating. So current can come from outside. But in this place, there is no floating line. To see this is where we want to start from. So what we just do is we just pick a point along the path. So let's say we just start from any point. So let me start from this edge. And let's move in this direction. So if current flows in this direction, it's going to flow round. You discover that current keep flowing without having to split. So in this circuit is also called a series connection. So our R is going to be R1 plus R2 plus R3 then plus R4. So in this case we are going to have 2 plus 2 plus 2 plus 2. So we are going to have 8 ohms. So let's look at example 5. So let's look at this example 5. I want to find equivalent resistance. If you look at example 5, it looks like example 4. Just that this one has a floating point, that is, current is coming from this place, not just any point around the circuit. So if current is coming from this point, you discover that the current splits into two at this point. So when it splits into two, part of the current will flow like this and part will flow like this. The part that flow like this flows through 2 and 2, telling me that this one and this one, they are series to each other. While the part that flows like this flows through these 2 and these 2, telling me that this one and this one, they are series to each other. So let's solve this series and then have a simplified circuit. So for this connection, we are going to have R equals to R1 plus R2. So we are going to have 2 plus 2 is going to be 4 ohms. So for this side, we are going to also have R equals to R1 plus R2. It's also going to be 2 plus 2, which is going to be 4 ohms. So it means this 2 has come together to be 4. This one has come together to be 4. So let's redraw the circuit and see how it's going to look like. So the circuit is going to now look like this. It's going to look like this now. It depends on how you want to draw it. So the circuit will now look like this. So which means this 2 has come together to become 4 ohms. This one has come together to be 4 ohms. So we now look at it. Let's trace from this source again. It's clear that when current gets here, it splits into these two. It splits into this before it comes out. And that is to tell us that this one and this one, they are now parallel to each other. When current is coming from here, at this point it splits into two. So they are now parallel to each other. So we now say 1 over R equals to 1 over R1 plus 1 over R2. So 1 over R equals to 1 over 4 plus 1 over 4. So the LCM is 4. So we are going to have 4 in 4. That's 1 plus 1. So 1 over R becomes 2 over 4. So if 1 over R is 2 over 4, cross multiply, then R is going to be 4 over 2. So R equals to 2 ohms. So when the circuit is in this form, the total resistance is 2 ohms. You see the difference now between this one and the previous one. The previous one gave us 8 ohms, while this one is giving us 2 ohms. So it depends on your ability to determine if the circuit is a parallel connection or is a series connection. That will determine whether you are going to get a correct result or not. So thank you for watching this video. So in the next video, we now begin to analyze the current that passes through each of the resistors and the voltage across each of the resistors. That is where we are actually heading to. But it's very important that you know how to find the total resistance in a circuit, total current in a circuit, total voltage in a circuit before you can start analyzing current through each of voltage or resistance of voltage through each of the resistor. Thanks you for watching this video. Make sure you subscribe to this YouTube channel, like this video, and make comment. Thanks and God bless you. So I will just set some of the questions that you can practice with. I'll put it on the board. You can just do those questions and give me feedback. Thank you. So you can just do these practice questions. So this practice question, each of them have the same resistance, and the resistance value is 2 ohms. So 2 ohms. Each of these value is 2 ohms. So make sure you work it out, and if you get it correctly, your answer should be 8 ohms. Thanks and God bless.